Hey guys, welcome to our fourth video on factorising and solving cubics. So here I'm going to run through two more questions of the trickier variety. So let's get cracking. Okay, for question 1 we've got f of x is 2x cubed minus 7x squared plus 25x minus 11, and part A asks us to show that 2x minus 1 is a factor of f of x, and then part B asks us to prove that it's the only factor and to state the value of the root. Okay, so for part A then, if 2x minus 1 is a factor, so if 2x minus 1 is a factor, then f of 1/2 will equal 0. So we need to find f of 1/2. So we're going to have two lots of 1/2 cubed. Minus 7 lots of 1/2 squared. And then plus 25 lots of 1/2. And then minus 11 at the end. Okay, so let's sort this out. So 1/2 cubed is 1/8. 2 times 1/8 is 1/4. 1/2 squared is 1/4. So minus 7 times that is minus 7 quarters. 25 times 1/2 is 25 halves. And then we got minus 11 at the end. Now, 1/4 minus 7 quarters is minus 6 quarters plus 25 halves minus 11. 6 quarters is, or minus 6 quarters is minus 3 halves. So we got minus 3 halves plus 25 halves minus 11. Minus 3 halves plus 25 halves is 22 halves minus 11. Now 22 halves is 22 divided by 2. So we got minus 11, sorry, we've got plus 11, minus 11, which does indeed equal 0. Therefore, 2x minus 1 is a factor. Good times. Now we can do part B. Okay, for part B then we want to prove that 2x minus 1 is the only factor and state the root. Well, we already know the root really. If 2x minus 1 is a factor, the root is equal to 1/2. So that's the value of the root. Now we want to prove it's the only one. So, to do that, we're going to have to write f of x as a linear factor, which we know is 2x minus 1 times a quadratic factor, and then show using the discriminant that the quadratic has no real roots. So we got 2x minus 1 lots of ax squared plus bx plus c, like that. Now we can work out a quite easily. we've got 2x cubed in f of x. When we expand this out, we're going to get 2x times ax squared, which would give us 2ax cubed. So a has to be 1. Good times. We can work out c quite easily too. A constant term in f of x is minus 11. When we expand this out, we're going to get minus 1 times c. So minus 1 times c has to be minus 11. So c has to be 11. Good times. So what we can do now, we can fill in the blanks a little bit in our quadratic part. So we can now say f of x is 2x minus 1 times just a single x squared plus bx plus 11. Now we need to find b the value of b. So, as I have done in all the previous examples, I'm going to find what x squared terms I would get if I was to expand this out. So, I would get 2x times bx. Now, 2x times bx is going to give me 2bx squared, and I'm also going to get a minus 1 times this x squared here. So we can get 2bx squared minus 1x squared, like that, which we can factorise to x squared times 2b minus 1. So there's our x squared term from the expansion. Now let's check how many x squareds we wanted. Up here we want minus 7x squared. So that tells us then 2b minus 1 is minus 7, like that. So if I add 1, I get 2b is equal to minus 6, and then if I divide by 2, we get b is equal to minus 3, like that. So, what we can do now then, is fill in our quadratic factor. So, f of x is 2x minus 1 times x squared minus 3x plus 11. Now, to prove that there are no more roots, we need to show that this quadratic has no more roots. So to do that, we find the discriminant. So the discriminant is going to be minus 3 squared, which is 9, minus 4 times 1 times 11. So that's going to be minus 44. Which is going to be minus 35. The important part there is that the discriminant is less than 0, which implies no real roots. So, x equals 1/2 is the only real root. Good times. Question 1 done. Okay, then for question 2 we want to solve 5x cubed minus 13x squared plus 4x plus 4 is equal to 0. To solve, we need to factorise. Factor theorem. Let's see if we can find one factor. So, let's try as always f of 1. So that's going to give us 5 minus 13 plus 4 plus 4. 5 minus 13 is minus 8, plus 4 is indeed 0. So, x minus 1 is a factor. Good times. Now, given that we've got 5x cubed, this one's probably going to be quite awkward. So I'm going to go down the linear and quadratic factor route. So we can now write this as x minus 1 times ax squared plus bx plus c. Well, we need to find the values of a, b and c. So, well, to get that 5x cubed, we know that a is going to have to be 5 and together plus 4 at the end. At the moment we got a minus 1. Minus 1 times c has to be positive 4. So that tells us then c is minus 4. So then minus 1 times minus 4 gives us the positive 4 that we need at the end. So we can rewrite the quadratic factor a bit. You can say we got x minus 1 times 5x squared plus bx minus 4, like that. Now we need to find the value of b. So again, I'm going to go for my x squareds from this expansion. So we're going to get x times bx squared, x times bx, which is going to give us bx squared, and then minus 1 times 5x squared is going to give us minus 5x squared. Now we can factorise that to b minus 5 lots of x squared. If we compare that to the x squared term that we want in the cubic, it's minus 13x squared. So b minus 5x squared is equal to minus 13x squared. If we divide the x squareds away, b minus 5 is equal to minus 13. Therefore, b is equal to minus 8. So, we can now write this as x minus 1 times 5x squared minus 8x, and then what was it at the end? Minus 4. Alright, good time. So now we need to see whether or not the quadratic part has any factors, or if that's it done. So to the discriminant we do go. So the discriminant is going to be minus 8 squared, so 64, minus 4 times 5 times minus 4. So that's going to give us a positive. It's a shame, that means there's more work to do. So 64 plus, well, 4 times 5 is 20, times 4 is 80. So again, the reason that we got a positive there is we're doing minus 4 times 5, which is minus 20 times minus 4 is positive 80. So we only really care that is greater than 0. So that does mean there are 2 real solutions. So we now need to solve them. Good time. Okay, so up to here we do already know one solution, which comes from our x minus 1 factor. So the first solution is x equals 1. Good times. So now to find the other two, we need to solve 5x squared minus 8x minus 4 is equal to 0. Good times. Okay, so purely because I hate using the formula, I'm going to complete the square here. So, oh, this is going to be completely horrible. Okay, so given that we've got an equals 0, we can divide the 5 away. So we're going to get x squared minus 8 fifths x minus 4 fifths is equal to 0. Now we can complete the square. So we're going to get x minus a half of 8 fifths. A half of 8 fifths is 4 fifths. Squared. Now we've got the minus 4 fifths on the outside. And then we also have to minus 4 fifths squared. Now 4 fifths squared is 16 25ths. So we're taking away 16 25ths like that. And that is equal to 0. Okay, so x minus 4 fifths squared. Well, so we want to combine these fractions now. So minus 4 fifths in terms of 20 fifths is minus 20 25ths. So we got minus 20 25ths minus 16 25ths. So we've actually got minus 36 25ths. So it's going to turn out a bit nicer than I thought. Is equal to 0. If we then add 36 25ths, x minus 4 fifths squared is equal to 36 25ths. If we then square root both sides, x minus 4 fifths is equal to plus or minus the square root of 36 25ths. Now the square root of that is 6 fifths. Good times. So then we get, if we add 4 fifths, x is equal to 4 fifths plus or minus 6 fifths. So we actually get 2 alright-ish solutions. So we'll get x is 4 fifths plus 6 fifths, which is 10 fifths, which is 2, or we get x equals 4 fifths minus 6 fifths, which is going to give us minus 2 fifths. So we could actually factorise that, as it turns out. I was just expecting it to be worse, And it was, but it doesn't matter because completing the square works just fine. Okay, there we go, then we've found our 3 solutions. That's it for this video then, guys. Next up, we are looking at algebraic division. It's great fun, everybody hates it,